Good morning, students. In the last class, we discussed about the capacitors and inductors which are connected to the AC source, right? So today we discuss AC voltage connected to series LCR circuit. Right? So series LCR means inductor, capacitor, and resistor, right? So consider an inductor of inductance L, right? So consider an inductor of inductance L and capacitor of capacitance C, right? And the resistor having the resistance R. So all these three are connected in series, right? So this we call as series LCR circuit, right? So consider an inductor having the inductance L and capacitor having the capacitance C and the resistor having the resistance. So inductance, capacitance and resistance are the intrinsic properties of the inductor, capacitor and resistance. So resistance means it opposes the flow of current in the circuit. So that is the property of a resistor, that is the resistance. So capacitance means it is the capacity of the charges which are stored in the capacitor. So that we call as the capacitor. So inductance is the EMF produced in the coil, right? So how much EMF it is producing, so that property is defined by the inductance, right? So now these three which are connected in series, so now connect this to the AC source, connected to the AC source of the voltage V is equals to Vm sin omega, right? So now I will write here V is equals to Vm sin omega t is the applied voltage for the series LCR circuit, and the current which is flowing across these three, that is inductor, capacitance and resistor, is given by I is the current which is flowing in the circuit. So that is given by I is equals to Im sin of omega t plus pi. So let pi be the phase angle or phase angle difference between the voltage and to that of the current, right? So where Vm is the peak voltage, Im is the peak current, right? So omega is the angular frequency and phi is the phase difference. Phi is the phase difference between the voltage and to that of the current, right? So now in the individual, when the inductor which is connected to the AC source, right? So the current which is flowing in the series, that means the current across these resistors having the common amplitude, that is common amplitude. So that magnitude is Im. So Im is the current which is flowing across these three components, right? So when the inductor is only connected with the AC source, so inductor the only with which we connected with the AC source, we getting, that is Vm, that is equals to Imxl, right? So this is VL. So voltage drop across the inductor, right? So this is the voltage drop across the inductor, that is VL, right? So the magnitude of the VL is given by VL is equals to Im into XL, where XL is the inductive reactance, right? So where XL is nothing but the resistance. So resistance into the current that gives for the voltage. That voltage drop is across the inductor, that is VL, right? So in the same manner, when the pure capacitor having capacitance C which is connected across the AC source, so there is a voltage drop, so that voltage drop will take on that one as VC, right? So again VC is equals to Im into XC, right? Where X is the capacitive reactance. This is also nothing but the resistance. So its unit is also equals to the resistance, that is ohm, right? So resistance into current, again we get in the voltage. So this voltage is across the capacitor, that is VC, right? So VC is the voltage drop across the capacitor. So series ಅಲ್ಲಿ ನಮಗೆ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, voltage divide ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So voltage across the inductor we taken VR and voltage across the capacitor we taken as VC, and voltage across the resistor we taken that one as VR, right? So VR is equals to Im into R, where R is the resistor and Im is the peak current. So maximum current flow ಆಗ್ತಿರೋದು in the circuit remains same irutte. So hence we taken Im as constant values here, right? So Im into VL, sorry, Im into XL, Im into XC, and Im into R, right? So now while we studying individual, so here XL is the resistance and VL relates with VM, that means voltage across the inductor relates with the current Im. So that means voltage leads the current by pi by 2. So ಇದನ್ನ ನಾವು each inductor, capacitor ಮತ್ತು resistance study ಮಾಡಬೇಕಾದ್ರೆ individually we find out that by using the phasor diagram we discuss that voltage leads the current by pi by 2, right? So similarly here voltage voltage, that is VL leads Im by pi by 2. So that is voltage leads the pi by 2. So here voltage is VL and current is Im. So similarly VC, voltage across the capacitor, lags the current Im again by 90 degree, that is pi by 2, right? So in case of resistance, V R and Im are in phase. So that means the phase difference between the voltage and to that of the current is 0. That's why we are taken that is in phase, right? So now by drawing the phasor diagram to relate with the VL, VC, VR with Im, right? So Im ಎಲ್ಲದರಲ್ಲೂ common ಇರೋದ್ರಿಂದ we relate with Im with VL, VC and VR, right? So taken VR and here somewhere Im. So this is in the case of resistance. So resistance ಅಲ್ಲಿ ನಾವು phasor diagram ಮಾಡಿದಾಗ both are in phase. So VR ಮತ್ತೆ current Im both are in phase, means the phase difference between these two is remains 0. So hence Vm and Ir both are in the same direction, right? So next VL, that is voltage leads the current. So here we have the current Im. So voltage leads the current by pi by 2. So leads means positive 90 degree, right? So that is here we have VL. So VL leads the current Im by 90 degree, that is pi by 2, right? So now VC lags Im by pi by 2. So lags means in the negative axis. So this gives what? VC, right? So lags the current Im by pi by 2, right? So this is the phasor diagram for series LCR circuit, right? So now considering the case if XC is greater than XL, right? So that means capacitive reactance is greater than XL, that means voltage VC is greater than VL, right? So now we can write this one as this we represent in the phasor. Phasor is nothing but the vectors, right? So we can take the resultant of these two, VC and VL. So resultant means, so VC has larger value and VC has lesser value. If we take the resultant VC minus VL, so that will be in this direction. So this gives what? VC minus VL. right? So otherwise I will write here mentioning labeling. OA represents what? So OA represents the voltage drop across the resistor R, and OB represents the voltage drop across inductor, and OC represents the voltage drop across the capacitor, and OD is the resultant of the two. When XC is greater than XL, that means voltage across capacitor is greater than voltage across the inductor. So we getting OD, so that value is VL, that is VC minus VL, right? So now we can neglect this one, right? So we get the resultant here, right? So we need to find the amplitude of the voltage V, right? So that's by constructing the parallelogram. So as these two are the vectors, again from the parallelogram law of vector addition. So if we draw the diagonal, so this diagonal gives what? Vm. So that is the peak voltage, right? So diagonal of the parallelogram gives what? The resultant Vm, and it makes the angle phi. That is the Vm makes angle phase difference with Im. So here phase difference is pi 0, and here the phase difference is pi by 2. The phase difference is pi by 2, and the phase difference between Vm and Im, that we taken as pi, right? So now from this triangle OA and VM, so calling this one as OE, right? So from triangle OAE, right? So from this triangle OAE, so here it gives the 90 degree. So from the Pythagoras theorem, OE square is equals to OA square plus AE square, right? So OA represents what? The magnitude of the voltage across the resistor, right? That is equals to BR square plus AE. So AE is equals to OD. That means it gives what? The voltage difference between the capacitor and to that of the inductor, right? So that is VC minus VL whole square, and OE square is VM square, right? So OE gives what? The magnitude of the peak voltage, that is VM, right? So Vm square, that is equals to Vr, we can write Im R whole square plus Vc, we can write Im Xc minus Im XL whole square, right? So Vm square, that is equals to, in all these terms we can take Im square as common, so we can write R square plus Xc minus XL whole square. So we need Vm, so Vm is equals to Im under square root of R square plus Xc minus XL whole square, right? So now we can take this one as Vm divided by Im, that is equals to under square root of R square plus Xc minus XL whole square. So here R, Xc, XL, all these are constants. So we can replace this term with the another constant. So that is we call Z, right? So now we can write this one as Vm by Im, that is equals to Z, where Z is equals to under square root of R square plus Xc minus XL whole square, where Z is called impedance, right? So where Z is called impedance. Impedance is nothing but the resistance which is offered or opposes the flow of current I in the series LCR circuit. So namge individually inductor study madbekare, here we are getting the resistance, so that resistance we call as inductive reactance, right? So in the same way, when capacitor is connected to the AC source, here also we getting the resistance, so that resistance we call that one as capacitive reactance. And also in the resistance, that is in the resistor we have the resistance, that one is R, right? So now, if all these three are connected and to an AC source, so here there is a flow of current from all these three components. It opposes the flow of current, right? So there is a resistance which is formed by all these three components. So that resistance we call as the impedance. So impedance is nothing but the resistance which offers the flow of current in the series LCR circuit, right? So we can observe V is equals to I into R, again from the Ohm's law. So Z acts as a resistance and its SI unit is again Ohm, right? C is the inductive reactance, Xc is the capacitive reactance, and R is the resistance. In the same way, Z is the resistance, which is the combination of all these three components. So ಈ ಮೂರು components ಇಂದ flow ಆಗ್ತಿರೋ current ನ oppose ಮಾಡ್ತಾ ಇದೆ. So ಅದಕ್ಕೆ ಒಂದು name ಕೊಟ್ಟಿದ್ದೀವಿ. So that name we call as the impedance. Impedance is nothing but the resistance which offers the, or it opposes the flow of current which is flowing in the series LCR circuit, right? So that one we call as the impedance, right? So by this, or Vm is equals to Z into Im, and this one is the important relation for the impedance, right? So impedance Z is equals to under square root of R square plus Xc minus XL whole square. So this is when if Xc is greater than XL, right? So now we need to find the phase difference. So phase difference between the peak voltage and to that of the peak current, right? So again from this triangle, so I will write here from triangle OAE tan pi, that is equals to, so from this tan pi is equals to opposite side by adjacent side. So opposite side is AE, adjacent side by is OE. So AE is parallel to that of the OD, so that we can write BC minus BL divided by OA is VR, right? So again substitute these values VL, BC, VR, right? So that is IM Xc minus Im XL divided by Im R. So in the numerator Im and in the denominator Im get cancels. So we get Xc minus XL divided by R. So this gives what? The phase difference between the voltage, peak voltage and to that of the current in series LCR circuit, right? So here this is one formula we can derive, or we can relate impedance, that is Vm by Im. So where impedance Z is under square root of R square plus Xc minus XL whole square, right? So this one is what the impedance, and here we getting the pi. So or we can write this one as pi is equals to tan inverse trigonometric function, right? So pi is equals to tan inverse of Xc minus XL divided by R, or we can write, or in the another form we can write by the same triangle cos pi, that is equal to positive. That means pi value we are getting here positive. That means this pi value is positive. That means voltage leads the current, right? So it becomes purely capacitive. So because if Xc is greater than XL means that series LCR circuit becomes purely capacitive. That means maximum reactance will be produced from the capacitor. So only less reactance will produce from the inductor and less resistance which is produced from the resistor, right? So when Xc is greater than XL, right? So in the same way when Xc is less than XL, then the series LCR circuit is becomes purely, that is phase difference is negative, right? So Xc is less than XL, XL value is more than Xc, that means the pi value we are getting minus. So hence it is becomes purely inductive, right? So in an inductive, so this is the inductive. So in inductive, what happens? Voltage leads the current. In capacitive, what happens? Voltage lags the current. So that we can apply here, right? So when Xc is greater than XL, right? So voltage lags the current, right? So when Xc is less than XL, then voltage leads the current. So this circuit becomes inductive when Xc is less than XL, it becomes purely capacitive when Xc is greater than XL, right? So these are the two cases and the phase difference pi, right? So from this, these are the important relations. One, that is Z is equals to Vm by Im, or we can relate, or we can find Im, that is the peak current Im is equals to Vm divided by under square root of R square plus Xc XL whole square. So possibility of asking this for 5 marks, right? So this is the method by using phasor diagram. So we find out the impedance in the circuit by the method of the phasor diagram. Phasor diagram means this diagram. So by using this diagram, we can find the value of current Im, that is equals to Vm divided by Z. So Z value is under square root of R square plus Xc minus X square, XL whole square, right? So for that, again same series, the voltage drops. So first we need to write the individual voltage drop across the inductor and then capacitor and then resistor. Now in the second step, we need to plot the phasor diagram, right? So first starts from the current and resistance, right? So Vm and IR are in phase, so we write both in the same direction. Next, voltage leads the current, so we taken that one as VL, and voltage BC, that is capacitor, voltage across the capacitor lags the current, so hence we taken in the downward direction. So ಇವೆರಡನ್ನು ನಾವು previous individual ಅಲ್ಲಿ ಏನು ಸ್ಟಡಿ ಮಾಡಿದೀವೋ ಅದನ್ನ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತಾರೆ. So here we having the three vectors, right? So VL, VR and VC. To find the resultant of these three vectors, first we need to find the resultant of VL and VC. So for that we consider the case that is Xc is greater than XL. That means voltage across the capacitor is greater than voltage across the inductor, right? So hence VC is greater than VL. So if we take on the resultant, both are in the opposite direction and the phase difference is 180 degrees. So we getting the resultant as VC minus VL. This is again from the triangle of resultant of two vectors. So one is in the upward direction and another one is in downward direction. So idu namge by using the vectors we can, so the resultant we use VC minus VL. Then we need to find the resultant of VC minus VL with the VR. So that means we getting the two vectors, right? So to find the resultant of two vectors, we need to draw the parallelogram. So here we getting the rectangle. So diagonal of the rectangle gives what the resultant voltage. So that voltage is what Vm, right? So by constructing the triangle by using Pythagoras theorem, we Vm by Im is equals to Z, right? So this is by using phasor diagram, right? So in the analytic method, right? So one more method to find the same relation by using analytic method. So ಎರಡರಲ್ಲಿ ಯಾವ ಮೆಥಡ್ ಬೇಕಾದರೂ 5 marks ಗೆ ಕೇಳಬಹುದು. So ತುಂಬಾ ಸಲ ಸೀರೀಸ್ LCR ಅಂತ just refer ಮಾಡಿದ್ರೆ you can choose any one method. Either you can derive by analytic method or you can derive by phasor diagram method. So problems ಕೇಳಿದ್ರು ಈ ಟಾಪಿಕ್ ಅಲ್ಲೇ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರೋದು ಸೀರೀಸ್ LCR ಸರ್ಕ್ಯೂಟ್. So analytic method. Next is right. Analytic method is purely based on the mathematics. Just a simplification and equating and simplifying, we get the impedance value, right? So first, that is the voltage across the inductor, voltage across the capacitor, and voltage across the resistor, right? So applying Kirchhoff voltage rule or voltage law to this circuit. So where I is the current which is flowing in the circuit. So Kirchhoff voltage law, what it states means sum of the IR product is equals to the number of EMF which is present in the circuit, right? So here IR product, that is EMF which is induced in the inductor, we can write that one as L into di by dt. So this is the EMF or voltage which is produced by the inductor, right? So plus voltage which is across the capacitor, right? So Q divided by C, where capacitance of a capacitor C is equals to Q by V. So V is equals to Q by C. We can write that one. That is the voltage which is across the capacitor, right? Plus voltage across the resistor, that is IR product, I into R, right? That is equals to the cell which is connected to this series, so that we write as V, right? So L into, we know that current I is equals to dq by dt. So this is from the definition of the current, that is rate of change of charges with respect time, right? So d by dt, so in place of I we can write dq by dt, right? Plus, so q divided by c, keeping as is, plus again here substituting the current R into dq by dt, that is equals to V, we written that one as Vm sin omega t, right? So now we can write this one as L into d square q by dt square plus R into dq by dt plus q by c, that is equals to Vm sin omega t, right? So this is in the form of second order differential equation, right? So this is in the form of second order differential equation. So if we solve this equation, we get one solution for the q. So namke algebraic expression is right. So ax square plus bx plus c, that is equals to 0. If we simplify this relation, we get the values of x. Either we can use by the formula, right? So x is equals to plus or minus b. So b minus b plus or minus root of b square minus 4ac by 2a, right? So this is for the quadratic equation, we get the solution of x. So this equation is similar to that of the quadratic equation, right? So that is d square q by dt square. So in each having the charge q, right? So if we simplify this relation, we getting a solution for the q, right? So ಇದು ನಿಮಗೆ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಬರುತ್ತೆ second order differential equation. So there are so many methods to simplify the given relation, right? So here we are directly writing. So if we simplify this relation, we getting one solution for q. So that is q is equals to qm sin of omega t plus theta, right? So if we simplify this relation, we getting one solution. So that solution is q is equals to qm sin of omega t plus theta, right? So now we need dq by dt, d square q by dt square, right? So differentiating this relation, we get dq by dt. That means differentiating this relation, we get qm omega. So if we differentiate sign, we get cos of omega t plus theta, right? So again further, if we differentiate d square q by dt square. So we getting minus qm omega square sine of omega t plus theta. Right? So E equation of further differential model, qm is a constant, keeping as is, omega first keeping as is. So if we differentiate cos, we getting minus sine of omega t plus theta. So in the interior again omega into t. So if we differentiate omega t, we getting omega. So omega into omega, we get omega square. Right? So now substituting these three solution to the given equation here. So we are calling this one as equation 1, right? So that means substitute all the above values in equation 1. So in this equation, right? So in place of L, keeping L as is, minus qm omega square sine of omega t plus theta, right? Next, plus r into dq by dt is qm omega into cos of omega t plus theta, plus in place of q you can write qm by c sin omega t, that is equals to vm sin omega t, right? So in this equation we can take common, that is qm into omega, where omega is the angular frequency. So all the three parts, so ಈ ಮೂರು part ಇಂದನು we can take qm as common, so that is minus qm omega. If we take in common, one omega is left into L sin of omega t plus theta. So in this qm omega, if we take common, r into cos of omega t plus theta. So here we have only qm. So along with the qm, if we take omega common, we get 1 by omega c sin omega t, that is equals to vm sin omega t, right? So this omega l, we can write that one again from the relation xl is equals to omega l and xc is equal to sin of omega t plus theta, right? So plus r into cos of omega t plus theta, that is equals to vm sin omega t. So analytic method is just simplifying the relations. Now multiply and divide by z. So above equation we are going to multiply and divide by the z. So ez in the above relation ನಾವು multiply ಮಾಡ್ತಿದೀವಿ, ಜೊತೆಗೆ divide ಮಾಡ್ಕೊಂತೀವಿ, right? So if we multiply here qm omega z, so divide means z by z, so we dividing this z inside the bracket, so we get so xc minus xl by z sin of omega t plus theta plus r by z cos of omega t plus theta, that is equals to ಇಲ್ಲಿ ಕೂಡ ನಾವು z divided by z ನೋಡಿದ್ರೆ z cancel ಆಗುತ್ತೆ, as is we can write vm sin omega t, right? So now put, that means substituting, put r by z is equals to cos pi. So this is, we are substituting, so putting r by z is equals to cos pi and xc minus xl by z, that is equals to sin pi. So we are substituting by replacing these values, r by z is equals to cos pi and xc minus xl divided by z is equals to sin pi. Now substitute these two in this equation, right? Calling this one as second equation. So tumba lengthy ಇದೆ, but it based on purely mathematics. So substitution and simplification. So previous phasor diagram use ಮಾಡಿದ್ರಲ್ಲಿ ನಮಗೆ physics ಇತ್ತು, but analytic method is purely based on mathematics, right? So substituting these two values here, right? Qm omega z. So in place of xc minus xl by z by sin phi, right? So sin phi, sin of omega t plus theta plus r by z by cos phi, right? So cos phi into cos of omega t plus theta, that is equals to Vm sin omega t, right? So this is in the form of cos A cos B plus sin A sin B, right? So Qm omega z, we can write this one as cos of A minus B, cos A cos B plus sin A sin B, that gives what? Cos of A plus B, right? So we taken this one as A and this one as B, right? So cos of omega t plus theta minus phi, right? So A B, cos A cos B plus sin A sin B, right? That is equals to Vm sin omega t, right? So now Qm omega z cos of omega t plus theta minus phi, that is equals to Vm cos of omega t minus phi, right? So sin omega t we can write cos of omega t minus pi by 2. So cos of 90 minus theta, again we getting sin theta, right? Now comparing these two equations, so LHS ಮತ್ತೆ RHS equals ಇದೆ ಅಂದ್ರೆ LHS terms ಅಲ್ಲಿ ಏನಿದೆ ಅದು RHS terms ಗೆ equal ಆಗುತ್ತೆ, right? So Qm omega z is equals to Vm, right? So that means we can write Vm is equals to Qm omega z. So same wise cos ಇದೆ, ಇಲ್ಲಿ ಕೂಡ cos ಇದೆ, right? So inside the cos, that is cos of an angle, that is equals to cos of an angle. So in place of omega t we having omega t, right? So in place of theta minus phi we are getting minus phi, right? So cos ಇದೆ, ಇಲ್ಲಿ ಕೂಡ cos ಇದೆ, omega t ಇದೆ, ಇಲ್ಲಿ ಕೂಡ omega t ಇದೆ. So from this we can write theta minus phi, that is equals to minus pi by 2, right? So comparing these two equations, so LHS is equals to RHS, and then the terms which having the values will be the same, right? So now we can write this one as Im, right? So Vm is equals to Im into Z. Again we get impedance Z is equals to Vm by Im, as this one we derived in the last, that is by using the phasors we derive the equation Z is equals to Vm by Im, right? So from this here, that is theta is equals to pi minus pi by 2, right? So if pi na right side shift madidre minus pi becomes plus pi, so theta is equals to pi minus pi by 2. So substitute the theta in this relation, right? So here if we substitute the theta, Qm omega cos of omega t plus pi minus pi by 2, right? So this becomes the whole term cos of pi by 2 minus theta, we can write this one as Qm omega sin of omega t plus pi, right? So dq by dt in the LHS we call this one as the current, right? So we can relate I is equals to Qm omega, that is sin of omega t plus pi. So hence we can relate this as I is equals to Im sin of omega t plus pi. So same we initially considered. So phasor diagrams of where I is the current which is flowing across the circuit, we getting I is equals to Im sin of omega t plus pi. Iduna now considered madidvi. So finally we getting the same relation, right? So in place of Im we having the value Qm omega. So that's also we are getting here Qm omega, right? So Vm is equals to Qm omega. We can replace this by the term that is Im, right? So that is impedance Z is equals to Vm divided by Im. So this is the method That is the analytic method. By using the analytic method, we can also find the impedance, right? That is Z is equals to Vm divided by Im, and the current which is flowing in the circuit is finding by I is equals to Im sin of omega t plus pi. Now we need to find, so now impedance find out model, current find out model, and the last remaining is the phase angle, right? So again by these two relations, right? So dividing, we call this one as equation 3 and this one as equation 4, right? So divide equation 3 by 4, right? So that is sin pi is equals to xc minus xl divided by z divided by cos pi whole divided by r by z. So z cancel. So sin pi by cos pi, we can write that one as tan pi. In the RHS, again we getting xc minus xl divided by r. So we getting the phase difference between the voltage and to that of the current, right? So this is by the analytic method. So analytic method is simplification. So ನೆನಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು, so first one is by taking common, and the second one is multiplying and dividing by z and substituting. So ಈ ಮೂರು ನೆನಪಲ್ಲಿ ಇದ್ದರೆ we can easily simplify. So whole is based on the simplification. So finally we find the relation for the impedance z and current I is equals to Im sin of omega t plus pi. So previous phasor diagram only starting here we consider that where I is the current which is flowing in the circuit. So in analytic method we find the current. So input we taken by the voltage. So voltage ಇಂದ ತಗೊಂಡು ನಾವೇನ್ ಫೈಂಡ್ ಮಾಡಿದೀವಿ current which is flowing in the circuit, right? So this is about series LCR circuit. So while problems, so phase angle and the impedance, the relation of the impedance z is equals to square root of r square plus xc minus xl whole square. So adu tumba important. And the last graphical representation. So in series LCR circuit, so this is the applied voltage V, right? So where V is equals to Vm sin omega t, right? So here we getting Vm, that is the peak voltage, and the current right. So this is what the current which is flowing in the series LCR circuit I, and here this value we getting, that is Im, right? So the phase, so this is what the phase pi, that is the phase difference between the voltage and to the current. So this is graphical representation for the series LCR circuit. So black line alirodu voltage and dotted red lines alirodu current, right? So in phasor diagrams, so if you plot this in the same in phasor diagrams, so this is what V, and here we have the I, and this angle is phase angle. So idu namage ಎಷ್ಟು ಬೇಕಾದರೂ ಇರಬಹುದು. So this becomes omega t, right? So this is phasor diagram. So ಇದನ್ನ ನಾವು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೊಂಡು ಇಲ್ಲಿ phasor diagram ಮಾಡ್ಕೋಬಹುದು, or in general we can write V and I. I leads the voltage by the phase, that is pi, because here we getting plus pi. So plus pi means current is leading the voltage by a factor. So that factor is pi. That means voltage in ಏನಾಗ್ತಿದೆ ನಮಗೆ getting the maximum value. So current maximum ಬಂದ್ಮೇಲೆ ನಮಗೆ voltage ಏನಾಗ್ತಿದೆ maximum reach ಆಗ್ತಿದೆ. So if you can observe here, so some, so ಇಲ್ಲಿಗೆ ನಮಗೆ exactly 90 degree ಇದೆ, that is pi by 2 90 degree ಬಂದಾಗ voltage ಏನಾಗ್ತಿದೆ maximum ಆಗ್ತಿದೆ. So before 90 degree the current is getting the maximum value, that means the peak value higher, either it may be 30 degree 35 40, so any angle, right? So voltage maximum ಬರಕ್ಕಿಂತ ಮುಂಚೆನೇ ನಮಗೆ current ಏನಾಗ್ತಿದೆ maximum ಬರ್ತಿದೆ. So hence current leads the voltage in series LCR circuit. So that lead or lag decided by plus pi. If it is minus pi, that means voltage leads the current. That means voltage is first reaches the maximum, then the current, right? So this is about series LCR circuit. So remaining related to this topic we will discuss in our next class. Thank you.